So what we're going to be doing in this lecture is kind of combining the two, like what's the importance of knowing multiplication and how you can apply that into division. So in order to get started, we have to first kind of understand some generalizations about special cases of divisions. So I'm going to ask you guys some questions, and feel free to kind of like respond in the chat function. But first off, what do you get when you divide a number by 1? So feel free to like text me in the chat, kind of like individually if you know the answers. Or you can even just say it out loud if you want, unmute yourself. Okay, yeah, I got it stays the same. Any other responses? Yeah, okay, so you basically get the same number, right? So if we're going to have 10 divided by 1, it'd still be 10. If you're going to have, let's say, 156 divided by 1, it's still 156. If you even get like a crazy number, like 9, 6, 7, 8, 2, 4, 3, 5, whatever divided by 1, it's still that crazy number. But why is it this way? So we know that in multiplication, it kind of is the same thing as an identity property, right? So 10 times 1 is only ever going to be 10. If you have 10 things and you give it to like one person, they're still going to have those 10 things. It's the same thing in that you're only dividing it amongst one person, you're only giving it to one person, and so you still have the same kind of identity rule. And this is a special case in division because anything divided by 1 still gets you the same number. Now what happens if, let's say, you get let's say that what happens when you divide a number by itself. Now what's the answer to this kind of special case? We said that if we divide a number by 1, you get the same number. But what happens when you divide the number by itself? Exactly, we just get 1. So, yes, yeah, exactly. And so, somebody else said, like, why can't you divide by 0? We're going to get into that, don't worry, for sure. I don't know if that's a question or if that's like a statement, but that's correct, and we will definitely get into that. But when you divide a number by itself, I guess if you say like opposite case being 0 divided by 0, then you're always going to get the same number. So 10 divided by 10, 12 divided by 12. And this is again because of the same reason. You have 12 things and you divide it amongst 12 people. And you can also think of it in terms of multiplication. If you take the same kind of like equation that we just did, 12 divided by 12 equals 1, we can always rearrange it to become another multiplication question. And when you do, you're basically going to be multiplying 12 on each side. So that now 12 is the same thing as 12 times 1. And this is something that we just established, that 12 times any number is still going to get you number 12. And 12 divided by 1 still gets you 12. But 12 divided by itself is still going to get you 1. And I know that I'm kind of like repeating the same concepts over and over again, but this becomes really especially important if you understand these basic concepts when it comes to doing more complex division. So finally, this kind of goes into why someone said, like, why can't you divide by 0? What happens when you actually divide 0 itself by another number? Let's say 0 divided by 100, or 0 divided by 9, 3, 6, 2, 5, 0. What's that? Does anybody know? Exactly. It's just going to be 0 again. So in this case, you can divide 0 by another number. But what you can't do, which someone already kind of pointed out, you can't divide 100 by 0. You can't divide this 936,250 by 0. And the reason why this doesn't make sense, as that you can kind of tell, is because if you have 100 things, let's say for example, but you have no one to give it to, there's no way that you can actually divide the number by. It's the same thing as saying like you had like 100 apples, let's say, and you have one person. Well, that person's going to get all the apples, right? He gets all 100 of them. Versus someone, a situation where you have 100 apples and you have 2 people. Well, again, you're going to have 50 apples per person. But if you have nobody, if there's not even one person, if there's not even 2 person, there's no possible way that you can actually divide those numbers because that 100 doesn't go into anything. And you can't say 0 either. because there's still some things that you can actually like give. You still have those 100 apples, but there's no possible way that you can divide it into nothing. This is different than the other scenario. Like the difference basically between 100, 0 divided by 100 versus 100 divided by 0 is that in this case you have 0 apples and you have 100 people. So when you divide 0 apples to 100 people, well, everybody is going to get nothing. That's why this answer is 0, because there's nothing to give in the first place. On the opposite side, you have 100 apples. You have 100 things that you're willing to give, but you have nobody receiving it. So there's no possible way that you can divide these 100 apples. There's no possible way that those 100 apples can go to anybody. And that's why we say like this situation like doesn't make sense, but this is also called being undefined. And this concept of being undefined actually becomes super important when you go on to like later math concepts. And this is kind of like the condition of where kind of like reach the stretches of reality, kind of like the limits of like what is definable, like what we can actually do with this. Because this kind of scenario where you have nothing divided by just obviously doesn't make sense. And you can't say 0 because 0 is already kind of defined for this situation and not the other situation. So I hope that these rules in general make sense. And these are kind of like the special cases that you guys need to remember whenever you are going to do situations like this, whenever you're going to be dividing. So now let's go into kind of the different multiples that are kind of important. So now we understand like what you can divide ones and zeros by, but let's see actually dividing multiples of 10. And I hope that like once we go over this, it kind of makes more sense why the kind of multiplication that we did before happens. But whenever we divide a number that ends in 1 or more zeros, so dividing by multiples of 10s or 100s or 1,000s or 10,000, it doesn't matter because they all end in zeros. It's useful to kind of relate this concept of division back to kind of multiplication. So the same thing where we divide 3,600 students, if we divide, let's say, 3,600 apples by 90 students, right? So we're going to say like apples by students. You can fill in the blanks of this like equation. So we try to find out what the answer is. Like we'll say that's x. It's the same thing as just saying 90 times x equals 3,600. Because again, you can multiply 90 by both sides and you cancel this out. And so you still get this answer. And so this is like where multiplication and division basically kind of connect. So we have our 3,600 and our x90, and we have our 90x and g60. And so basically what we're trying to show here in these cases is that these zeros mean kind of nothing. You can kind of get rid of them. You don't have to worry about them for now. Let's just focus on the numbers that we actually do see. So in situations where you have these are like multiples of 10s, multiples of like big zero numbers, all you have to worry about is just the 36 and 90. So this is kind of simple math. Like we already know what 36 divided by 9 is. Like if you remember your 4s tables or your 9s tables, again, this is just going to be our 4. But now that you kind of got rid of these parts of your equation, all you have left are your zeros. So what you can remember is that the zeros automatically cancel out with one another. So 1 0 at the bottom will take out 1 0 at the top, so you're only left with the 0 up here. So our answer at the end of the day is just only going to be 40. So if we're going to look at another example, you can do this with kind of like any big number multiples of 10s. So let's look at this big crazy number. Let's say like 72, 0, 0, 0, 0, 0, 0, 0, 0, divided by 9, 0, 0, 0, 0, 0. Okay? Like these numbers might look intimidating. Like this is even more than a million, I think. Yeah, it's even more than a million. And then this one is 900,000. And so these numbers might look like really big, but because they're only by zeros, they're actually really simple to look at. Again, just focus on the 72 and 9. We know our 9's table, so 72 divided by 9 is just going to be our 8. And all you have to do is just cancel out the zeros from the tops and bottoms. So cancel out these zeros, cancel out these zeros, and kind of go along the way. So when you cancel out like basically 5 zeros at the bottom and 5 zeros at the top, we're only left with 3 zeros. So our answer is just basically 8,000. And that's it. So that's why dividing by tens, like any multiples of tens, no matter how big or crazy the number gets, if they always end in zeros, it's really easy to kind of answer these questions. And again, like just relating it back into multiplication, this is the same thing that we did when we used the distributive property and tried to separate our big complicated numbers into groups of 100s and tens and ones, because it goes back to this concept that these zeros can always be canceled out with each other, and it just makes more sense.